Understanding metals and nonmetals.
Learning about reaction of metals and nonmetals. How do metals and nonmetals react? We learned that noble gases, which have a completely filled valence shell, show little chemical activity. We therefore explain the reactivity of elements as a tendency to attain a completely filled valence shell. Let us have a look at the electronic configuration of noble gases and some metals and nonmetals. Sodium atom has one electron in its outermost shell. If it loses the electron from its M shell, then its L shell now becomes the outermost shell, and that has a stable octet. Nucleus of this atom still has 11 protons, but the number of electrons has become 10. So, there is a net positive charge given us a sodium cation, Na+. On the other hand, chlorine has 7 electrons in its outermost shell, and it requires one more electron to complete its octet. If sodium and chlorine were to react, the electron lost by sodium could be taken up by chlorine. After gaining an electron, the chlorine atom gets a unit negative charge because its nucleus has 17 protons and there are 18 electrons in its K, L, and M shells. This gives us a chlorine anion, Cl-. So both these elements can have a give and take relation between them as follows. Formation of sodium chloride. Sodium and chloride ions, being oppositely charged, attract each other and are held by strong electrostatic forces of attraction to exist as sodium chloride, NaCl. It should be noted that sodium chloride does not exist as molecules but aggregates of oppositely charged ions. Properties of ionic compounds. To learn about the properties of ionic compounds, let us perform the following activity. Activity. Take a small amount of sodium chloride on a metal spatula having an insulated handle. Heat it directly over the flame of a burner. We will see that sodium chloride does not melt easily. Sodium chloride melts and becomes a liquid only on strong heating. Conduction of electricity. Fill the beaker half with salt solution NaCl. 2 carbon rods made of graphite are placed in the salt solution in the beaker. An electric circuit is then set up by including a battery, a bulb, and a switch. Let us now press the switch. On pressing the switch, the bulb lights up at once. This means that the salt solution taken in the beaker allows the electric current to pass through it. In other words, the salt solution conducts electricity. Since salt solution is an ionic compound, in general, we can say that ionic compound conduct electricity when dissolved in water. Testing the conductivity of a salt solution. Table showing melting and boiling points of some ionic compounds. Summary. Compounds are solids and are somewhat hard because of the strong force of attraction between the positive and negative ions. Ionic compounds have high melting and boiling points. This is because a considerable amount of energy is required to break the strong inter-ionic attraction. Electrovalent compounds are generally soluble in water and insoluble in solvents such as kerosene, petrol, etc. Ionic compounds in the solid state do not conduct electricity because movement of ions in the solid is not possible due to the rigid structure. But ion compounds conduct electricity in the molten state. That is all in this topic, students. Let us learn about occurrence of metals.